In this video, we're going to talk about our circular functions. And our circular functions are just another way of representing all of your trigonometric functions in a slightly different way. So it's a different way of looking at them. Okay, so I drew a circle on the board here, and I want to mark a couple of different points. I want to mark these points with coordinates. And the reason I want to do that is because I want you to know that this is what's called a unit circle. A unit circle has a radius of 1 unit. Okay, so I marked a point on this, and I'm going to put a point on here. This is 0, 1. So the radius of this circle is 1. So now I want you to think back in our, I think it was our last video, where we talked about arc length. And we said our arc length, S, is equal to our angle in radians times our radius. Okay, and we said that because when we mapped out a radian, right, when we mapped out 1 radian, the arc length was equal to the radius. If we did 2 radians, the arc length, we added another radius here, so our arc length would be 2 radians times our radius, 2 times our radius. If we marked out a third one, we were over here slightly, and our arc length would be 3 radians times our radius. But on a unit circle, what is our radius? On a unit circle, our radius is 1. So when we talk about arc length on a unit circle, our arc length is really just equal to our radian angle measure. So if I mapped this out right here, if this is theta, theta is 1 radian here, that means that we have a unit of 1 for our arc length. This is 2 radians, because our radius is 1, 2 units for our arc length. This angle inside here, 3 radians. What would our arc length be? 1, 2, 3 units for our arc length. And so you can see that if your radian is 3, your arc length is also 3. And that works on a unit circle only. Our unit circle is going to be something we're going to move forward with, and understanding how our unit circle works is really important. So now let me mark a dot right here. Maybe I'll use purple to make it a little bit clearer. Okay, here's a dot. And let's mark it with coordinates x, comma, y. All right. So in most of our cases, if we had the sine of theta, the sine of theta is typically y over r. Okay, but for our circular functions, because theta is the same as our arc length, theta and our arc length are the same, I can go ahead and change this from theta to s, our arc length. And what else can we change? We can also change r. r is 1. So we can rewrite this as y over 1. y over 1 is really just y. Okay, and we can do the same with all of our trigonometric functions. Because theta and arc length are the same, I can say the cosine of s would be x over r, and we know r is 1, so it's just x. The tangent of s, and remember, theta is s in a unit circle, they're both equal. The tangent of s would be y over x. How about our reciprocal functions? Well, our cosecant of s is now, because our radius is 1, it's 1 over y. Our secant of s is 1 over x, and our cotangent of s is x over y. This is just another way of looking at our trigonometric functions, and we're going to be using our unit circle for forever. So some students like to look at it in terms of your arc length. Some students like to put that theta in here. I'm not going to care. You can substitute theta in for s if you want. You're going to see me do that a lot on the board. Instead of writing an arc length, I'm going to write theta instead of s. So we could substitute that in for s in all of these. And in our unit circle, we would just replace r with 1 and simplify. So it doesn't really matter to me how you do it, but this is a unit circle, and this is what we are going to be using moving forward in trigonometry.